All right, page 4. I'm going to show you, most of these are pretty quick and easy. Tangents can be a little tricky. I've drawn a little diagram of the old tangent on here when we get there. But cosine is probably going to be pretty fast for us. So let's look at cosine here real quick. Again, we got our equations up top. We see this one is probably going to be either sine or cosine. I would definitely do cosine even if they didn't list it, because I do cosine every time it starts at the bottom or the top, and this one starts at the bottom. First thing you want to do is you want to find the middle. So it goes up to 1, comes down to -5. The middle is going to be -2. That would give me 3 up to 1 and 3 down to -5, and that is going to be my k value. So my k is -2. Then you want to find your a value off your amplitude. That tells you how far up and down you go from the midline. It looks like that's 3. So my a value is at least 3, and since cosine usually starts at the top and this starts at the bottom, I'm going to make that a -3. H is unneeded because, again, I'm starting at the top or the bottom, so I don't have to slide this over after I flip it over the x-axis. So what I do need is b, and I get that with a period. So my period looks to be 2 pi. That is the first time I'm at the bottom going up again, it's 2 pi. So my b is 1 and I'm done. Literally, I've got everything I need. I go y equals -3 times the cosine of x minus 2, finished. I'm going to go down to this guy really quick. It's a little bit different, right? If they give you these, this will be your halfway point right here. All right, we can see that line right there, and that's going to be my k. My k is 1. All right. I can show you a lot of things. I know what my a is going to be, right? Because the first time I move over a quarter of a period, I go up 1, 2, 3, and the first time I move a quarter down here, I go. So it is going to be a is going to be 3 or -3. And if you remember, the standard tangent goes down to up. This goes high to low, so it's going to be a -3. Couple things. First, my period has changed. The standard period is between -pi-halves and pi-halves. All right, that's a period of 1. This one has a period of, well, my goodness, it looks like it has a period from here to here, so it has a period of 2 pi. So my b is 2. To get that, you would just say, hey, you know what? 2 pi is equal to the standard period times b. b has to be 2. And then I have to shift this over, right? So let's say all I did was make b 2. All right, that would stretch me out to here. All right, and that would stretch me out to here. So now it has to shift over to start there. So I have to shift to the right, right? Pi. So my h is going to be pi. Always remember, right? Always remember to apply your b before your h. And it looks like I've got it. It's going to be y equals -3 times the tangent of b is 2, so we're going to say 1/2. And then we're going to say x minus pi, there's my h, plus 1. Alright, got another one here. They tell us the sine function, which is good because it starts in the middle. Let's find the middle. Looks like the middle is at -1 right here. It's going to be my h. Oh, messed up. That's going to be my k. My k is -1. From there I go down, looks like 2 and up 2, so my a is either going to be 2 or -2. And since it starts in the middle going down instead of the middle going up like most sine graphs, it's going to be a -2. There is no need to scoot this over, so my h is 0. And let's figure out our b. Standard period is 2 pi. Let's see what a standard period here. The next time I'm going in the middle and going down is right here. So that's a full cycle. Looks like pi, so b is going to be 1/2. To change that 2 pi into pi, and I write it. So I got y equals, we got -2 times the sine of b, which is flipped over, of 2 times x minus h, which is 0, plus k, -1. And I circle that one. So we're done. So these problems will be a little tougher. If you need some practice, let me know. All right. How could you write a sine function from a cosine function? First described by sample 2a. Well, a sine function, if I did everything but h, would start right here, right in the middle going up. So I'd have to take it and I'd have to make my h value negative pi halves to back up. Alright, so I'm going to say h would equal negative pi halves, horizontal shift. Alright, basically the same function except the starting point. Alright, what is true generally about the graph of a tangent function? When a is less than 1 and when a is greater than 1. Well, when a is greater than 0, always increasing. We talked about that when we did it. When a is less than 0, always decreasing. I'm going to show you what I mean before we pause this. So a is less than 0 right here, and it's always decreasing. Sure, there's a gap and it shoots back up, but it's decreasing again. There's not a point on this line, we should have arrows here, that it is increasing. So there's page 4. I'm going to pause it.